Hi guys, okay, this is the first of my 3 examples lessons. So these are all past paper questions, and I'm going to go through kind of how I want you to deal with these or think about them. So given all this information, kind of written here as well, it says find the angle of BDC, right? The first thing we'll do is we'll write down what we're looking for. We're trying to find this angle here. Let's call it X. You can call these angles anything you want if it helps you. And it says give a reason for each stage of your working. Now this is very important, guys. There are marks, usually like 2 marks for the reasons. So make sure you write down the reasons. So you can mess around up here. You can draw whatever you want on this diagram, and then we'll write the reasons down here. So what do we know? Well, there's 2 circle theorems that stand out straight away to me here, guys. One is angles in the same segment are equal. So see this 28 here? This guy is also 28. So I can actually write this down here. I'm going to write angle CAD, angle CAD equals 28 degrees. And in brackets, this is the reason. Just write angles in same segment. Angles in same segment are equal. So he wants you to write down the circle theorem. Okay, fine. Then there's another one, guys. This is the center. This is a diameter. So when you see that, you're going to have to start thinking, which of the circle theorems is there? Is there an angle here in this semicircle? And there is. This guy, ACD. So angle ACD equals 90 degrees. Again, in brackets, angle in semicircle equals or is 90 degrees. And then finally, this is a triangle, this one here. So I can just say 28 plus 90 plus 32 plus X equals 180, because angles in a triangle add up to 180. I don't think you actually need to write down that reasoning here, guys. But if you want to be super safe, do say angles in triangle add to 180, and then you can just find out what X is by doing, well, whatever, that's 20 plus 32, that's 60, that's 150. So that is 150 plus 30, so X is equal to 30 degrees. Okay, so there we have angle in a semicircle, and we've angles in the same segment. Okay, next one. Again, annoyingly, he said give reasons for your working, so we're gonna have to do that. This is 52. We're trying to find out ABC. So we're trying to find this angle here. I'll call it X, and I'll put that there like that. Okay, now straight away, guys, I see this is the angle at the circumference. This is the angle at the center. So this is going to be twice that. But let's figure some things out first. And also here we have this kind of radius triangle. So this one is 52. This is 52 degrees. And now you can actually see, guys, how we're going to find that one from a triangle, and then just half it to give me this one. So let's write out our reasons though. Angle ACO equals 52. In brackets, isosceles triangle. That's all I need to say. Then angle AOC is equal to, that's it's 180 minus 52 minus 52. That's 104, which means that is 76. So that's 76. That's just from a triangle. And then finally, angle ABC, which is what we're trying to find, is going to be half that, which is 38 degrees. And I'll just in brackets, angle at circumference is half angle at center. Okay, last question. Question 16. L, M, and P are points on a circle. Okay, so straight away I see a quadrilateral here, guys. In fact, straight away, look, without even reading the question, I can write in here 1, 2, 2, 1, 2, 2 degrees, because these two opposite angles in a cyclic quadrilateral add up to 180. Now, what are we trying to find? We're trying to find M. Oh, well, sorry, that was the question, guys. 1, 2, 2. Well, that was the first one. And then I can say opposite angles. What's the reason? Opposite MLP, opposite angle. It's only worth 2 marks, so 1 for that and 1 for this. Opposite angles in cyclic quadrilateral add to 180. And then he says find the size of the reflex angle MOP. So that's this one here. Okay, now that's a bit like the one I said, guys. Angle at the center. Now he hasn't asked for a reason here. So the angle at the center is double this, so I need to multiply it by 2. So it's 122 times 2, which is 244, because this angle is twice that, because it's the angle at the center is double the angle at the circumference. Okay, so that's the first example lesson. I'll see you in the next one.